Hello everyone, I'm sure you're doing awesome. So, now that we have gained some good understanding around the idea of the indexing, so we will now go further and understand two very basic nuances around the querying capabilities of database. That is how exactly we can leverage index. Although we know it theoretically, we are going to see it in practical use right now. Plus, we also are going to see that what exactly is a query planning. For example, how internally a database engine processes the information beforehand before executing a SQL query. If that statement is not clear to you, it will be clear by the time we take you through some real world examples. But still, for better understanding, I will just write it down for you that what exactly is a query planning. So query planning is, so this is a process by which DB engine decides how to execute a query. So for example, a very simple query, suppose select star from orders, like I have order tables. When I do, what exactly the DB engine create behind the scene is it creates some plans. So those plans are nothing but some strategies, and then it evaluates that what is the best strategy to go ahead, and it chooses the most efficient one based on the statistics, indexes, and the other estimated cost. So again, we are going to see two very basic things on this. One is the explain and another one is the explain analyze, and we will see what goes behind the scene during this execution. So let's get into a demo that will give us a way more leverage towards the understanding what happens during the explain. So I have just opened my PowerShell, and over there I already have created one basic Postgres SQL, the Docker instance. So I'm just going to start with this. So here you can see like I'm currently into the Postgres console. So if you are not very familiar with Docker, it's completely fine. So what this thing will do is this will help me to execute some queries, and then very easily I can go to my Docker desktop and just get away with those instance. That is why I'm using this Docker instance of the Postgres. So now what I'm going to do over here is I'm going to create a table and I'm going to populate some data. So for example, over there, what we are going to do is like just take an example like book my show. There I'm going to create a table like seats, and over there some very basic fields will be there like the seat ID and whether it is available or booked. Those sort of information I'm going to hold into my table. Okay, and then while querying that particular database or to querying this particular table, I'm going to see and explore what exactly going behind the scene with index or without index. So it will be again a exploration of the actual cost estimation that the database does. So let's get into this. So here you can see like I have just created a table called seats, and it has like the seat ID, whether the status is available or not, and then what is the price point of that. Okay, and on top of this, what I'm going to do is I'm going to populate the result or populate the table with around millions of data. So I'm going to write a very simple insert into that, through which there will be almost million data will be inserted into this. So I'm going to give you a very brief idea what this query is doing or what this insert into statement is doing. It is generating a sequence of from 1 to 1 million. So this is the core of the operations, right? It creates a virtual table and with a single integer column containing 1 to 1 million, and each number of the ID is generated, and then we concatenate the letter S with a unique seat ID. And over here you can see this thing is happening, right? Like see it's like s that the one that we are concatenating, and then we are adding a constant shift to this number. So now if I do like a select star from seats, something like limit 100 suppose. Okay, if I do this, you can see over here all these numbers are getting all these rows are getting populated, and it is basically like with s1 s2, like s is the prefix, and from 1 to million, this is the number that we have populated over here. This is being marked into the seat, and over here you can see the available, maintenance, reserved. There are mostly three sort of categories that we have written over there. Okay, so now let's see. I mean, if I just I have limited it to like around 100, so only 100 rows will be seen here. But anyway, like we can total 1 million rows are there. So this is a pretty huge table, I would say. So now I'm going to try this particular statement. Explain select star from seats where seats status equal to available. One thing I want to highlight to you is, like, when we are looking into this, we just have created this table. This table doesn't have any index, so this is a pretty flat table right now. So let's see how does this query that we are going to or the statement that we are going to use, how what exactly we get when we are writing this explain. So I'm going to do this. So over here, you see this is the particular query plan we got. So let's break it level by level. So let's look into the output in detail right now. Okay. So the first thing that I would like to bring to your notice is this part, this this ACQ or the sequential scan. Okay. So what exactly is a sequential scan is? So if we do not have an index, that means for every single record to be for any where condition, it has to go through every single record. So it tells us that PostgreSQL's plan is to read the table row by row, and it's an agonizing process, right? So this sequential scan means like the row by row Postgres is going to read the table, right? And from the very beginning to end, like there is no sorting, or there is no cutout, anything, there is no filtration. So this is from begin to end. We are going to the Postgres is going to read the table complete row by row. So now it is more like if I have to take an analogy of reading a novel sort of a thing. So imagine like you are reading a 1,000-page novels, okay, and out of that 1,000 page, if you are being given a task to find every single word, the okay, so you don't have any index to find out, like agonizingly you go to every single line, every single page, and you find all the particular word that has been given to you. And this is what exactly this sequential scan is. And over here, as you see, this is what this particular thing meant, that sequential scan. Okay, and what are the numbers in parentheses? Let's look into that now. So at first we see this is the cost. So what does this cost means? So now that we know this, so what does this cost means? So this is the most important number comparing your query plan. So cost, I must say, like, this is the most important one. Suppose your juniors are being given two queries, okay, and they are asking you like which one do you think is the best one. So even before analyzing it, if you just do an explain, that will give you some idea with the cost, that what exactly is the query plan is going to do. So it is not measured in seconds, okay, but it is basically a UOW, or a unit of work. It is related to the disk reads and the CPU work. Okay. So over here, as we see, like something like 002.197 19507, right? 19507.00. So what does it mean? So the first one, this one is the startup cost. Okay, so this one is the startup cost. So what exactly is the startup cost for a sequential scan? It is always zero because it can just start the reading immediately. But keep an eye on this startup cost. The moment we shift to our index scan, or like the moment we create our index and then do the scan, we will see that this startup cost generally changes. Okay, and this is the total cost, and this is the estimated work, again not measured in second. This is the estimated work in terms of the CPU read write. Okay, in terms of the CPU read write, and what is the time to finish the entire scan. And our eye will be always into this, like whenever we are reviewing any queries. Okay, be it in any database, our eyes will always be into this estimated work. This needs to be minimized. So our goal as like the database developer or the application developer will be always to make this number as minimal as possible. Okay, now coming here, there are few other important things also. You see there is this the number of rows. So what does this number of rows tells you? This rows 3 3 2 700. So what does this number signifies? This basically tells us the estimated number of rows that our match that our condition matches. Okay, and here Postgres is very intelligent. So how does it know this? Like you might be thinking that how does Postgres before even executing it uh, came to know that this many number of rows will be there? So since we inserted like three different statuses randomly, like if you just remember in our PowerShell, we have put three different numbers, right? So Postgres already have a track into this insert into statement. So what generally it does is it knows out of those million records, probably one third of it was the rows with the status of available. So it gives you exactly that number. Okay, and other than that also you see this width 23. It is not a very important right now. It is critical. It is not very critical for like our understanding. But again, it is the width is generally nothing but the estimated average data size. Okay, the width represent estimated average data size. So now we got the idea of all of these three things. The first one is, as you can see over there, is sequential scan. We understood what exactly is a sequential scan. We understood these two numbers. This is the startup cost and this is the actual cost. We understood the number of rows. All these things we understood, and plus what exactly is our filter status. That also we kind of get an idea, but like I will just explain it to you. So filter means that every single row it reads on applying this filter, nothing else. It is a just whatever the thing that we have written in our where condition, it is telling us that. And this line says during my sequential scan of 1 million rows I will check each one whether the status is available or not. So putting it all together, I think this part now it is very much clear to us that what exactly explain is doing. Now we are going to see the output of the explain analyze. So what exactly is the difference between the explain and the explain analyze? We are going to see, and what important data point it gives us, that also we are going to check. So this is the data that we get out of the explain analyze, and let's discuss it in way more detail. What does this data signifies? So I just copy pasted that part over here for our better explanation. Just understand this thing here. In this part, the query is not executed. Okay. So in this level, definitely the query is not executed. Now, over here, what it does is it gives you the actual report card by executing the query. So what exactly is the difference here? This command, I will just write it here. It actually runs the query. So in previous case, the query didn't run. It just estimated the plan. And then it tells us how the plan performed in real world. Okay, or out in the field, like while executing it with our actual database engine, how it have worked. So again, let us see. So the first part that we see, all these details like the sequential scan on sets, something something something, that the cost, the rows, and the actual time taken. So let's discuss all these things. So the first part, that is the cost and the row. This part, it was the prediction. Okay. So when we see this part, this tells you that this was the prediction of the planner, and it predicted that the cost would be prediction that the cost would be around this number 19507. All right. Now, from here, what happens is the what is the actual time taken in that very next, or the very next statement that we see, that is the coming as the actual field reality. Okay, so the actual time that is being taken over there, we see is this number, right? Like the actual time. So this tells you the time it took, like this number is basically the time took taken to get the first row, to get the very first row, because it is like by what time it gets the first available column, right? The first status, first seat with the status available. And this tells you, this number, this tells you the total time it took to get the last row, total time to get the last row, right? So these numbers are like, again, one thing I should write here, are measured in milliseconds. Okay, these are milliseconds number. Now also we see that there is something called loops. Loops means it tells you that it executed one time, and this gives you the number of rows, like this part that you see over there, the rows, right? The rows that over there which you see, important thing is that this was the prediction, and it is very very close, right? Because it's a 1 million table. It is not that 100 or 200 records are there. That's why I put so many number of records, but you see it is very close. So over here, the point that I'm trying to make is, this rows, these are the actual number of rows that match the filter, and you can see the planner's estimate there at earlier level, and what exactly the planner has given you the rows. And now comes the line number 2 and 3. These are quite similar, like the number, what exactly it is trying to filter. And this has an interesting number again, the rows removed by the filter. It tells you that the exactly how much work was wasted, right? So the filter has to remove this number of like 6 lakhs or like more than 600,000 of rows it has to remove. So if you just add these two things, for example, if you just add this number, this rows plus this filter, it will come to that 1 million rows that we have inserted. But the main concern over here is it had to throw this many number of record. So like this rows removed by, that means like it tells that the CPU has has to read, and then it has to discard those things. Okay, so definitely it is a kind of a place where we could do some improvement. Right now, how the data was accessed can be seen in this part of the buffer. So there is a shared heat of 7007. This is a more advanced number, but like still it is a useful metric. I will just give you a very brief idea on this. So this means that 7007 blocks of data needed for this query, and they were found already in the memory, like in the cache hit, and this is very fast. So that is why it is said the shared read. And it would mean that it had to go to a like a slow physical disk to get the data, or rather, like shared hit means it doesn't have to go to get the data from the actual physical memory. Shared read, there is another parameter. If all the hits comes from there, then what would happen is it would take the data into that shared read part. But because in our over here we just did the insert into and stuff, so all this data was already into our memory, so it was a cache read that has happened. But anyway, we do not have to worry much about this part of this buffers part. But it tells you a very important aspect, like when you go further deep down into it. So now if we just see the final time, the final two lines, it tells that this much amount of time it takes to plan and this much amount of time to execute. So this is a very important thing, guys. Like just understand this, that whenever any planning that is being going on, so no no DB engine blindly execute anything. It does the planning, and once through the planning it find that this is the best possible path, or this is the best possible way it can go ahead, then this is the final execution and total time taken. So again, guys, these numbers are in milliseconds, so you can see how beautifully this whole things is going around, or around the database engine. And anyway, now the next step that we are going to take is, the next step would be, we are going to create index. We are going to create our index, and after creating the index, we are going to see how exactly our data has improved, the overall performance have been improved in our data. So now I have created an index over here, and here also important nuances I need, I want to explain it to you. Like now that we have created the index, okay, now that index is being created over here. So what would happen is, now the DB engine would scan the entire table. It scan the entire table and it builds the B plus tree that we discussed in our previous video, right? It builds the B plus tree for indexing purpose, and all the existing rows are included in this time. The only thing is that the point that I want to make you aware is, during indexing of a million row table, like in our case. Okay, whatever the things that we are seeing in our case, this operations of building the index, operation of building the index might, this might actually block or the log the table. Okay, because if the data keep on changing during the indexing process, then the indexing also might go wrong, right? So there is a certain sluggishness might be seen on that very fraction of second when the index creation is being done. So this is a point of a very subtle performance consideration. But like if we are not dealing with like a million reads per minute, then I think we are pretty good. We can actually deal with this kind of creation of the indexes anytime. So now that we have created an index, let's see how our explain and the explain analyze all the query planning behaves now. So here I have executed the explain select from star, select star from seats where seat is available, and there are very uh, different numbers we get. You can see previously it was sequence, now it is a bitmap hit scan. So I will just explain all of this thing to you in detail. Let me go to the Excalibur and like write the whole thing for you. So here we got some super interesting number and the conversation and the few of the plans details over here. So at first over here you see, once we have run that this explain command of after creating the index, what has happened over here is this plan is different, and previously it was sequential scan, right? When we see over here it was sequential scan, and now it is a bitmap heap scan. So what exactly are the difference between the sequential and the bitmap heap scan? Let's discuss at in the start. So it tells you a very simple thing, that the statement over here is quite clear. The bitmap heap scan on seeds. Okay, that means this line and this line, they are almost kind of very much important over here is over here. So this line tells you that the PostgreSQL DB engine now using the new index, the IDX seed status, and the index scan part means it is reading the index, not the main table. So this is the difference from here, right? This was a sequential scan. Over here we see that this is a bitmap hit scan, and plus we see this is a bitmap index scan on this particular index. So it has started reading the index. Now, instead of fetching each row from the main table one by one, it creates a bitmap in the memory. That is why it's a bitmap index scan. So we are going to cover a little bit more details into the bitmap index scan right after we complete our total lessons around the explain and the explain analyze of the index, what exactly goes behind the scene for the bitmap index scan. But r- just understand this thing, it creates its own map. Okay, it creates its own map for the efficient indexing, and then what it does is it create all the entries around there that says available, and it places a mark on the map corresponding to the actual row. So it is basically like maintaining a map of all the available status rows. Okay, and also the first information that we saw here is the bitmap heap scan on seats. What does it mean? This means that it moves the main table. So putting both of these things together, now this guy is like on this part, this guy is not in the bitmap, it is not really taking all the rows, right? What it is creating, it is creating the physical, it is just holding the physical location of all the given rows, like this row or this row, it is just holding the physical location. physical location of them. Now coming to this bitmap heap scan, what it tells is it moves on the main table, like all the main table data. It will now, this is the map that has created, and there is also my table data, right? There is my table data. So this table data has all of this, the actual physical locations where all the data are being stored. So what this guy would do now is, this process is, it will take all the physical location, it will keep on getting the data from here. As simple as that. Nothing else, nothing more. So it will just take the data from here. This physical location will also take the data from here, and out of that it will create its the actual record finale or the actual final record set. Okay, so like this is the map. The important part to understand is this is the map, and this is the table that we have in our case. Okay, so here bitmap heap scan reads the data from the table in a much more sequential and the efficient way than we had it in our earlier case. Okay, so that is why this sort of things, I mean, these are the internal data structure that the database maintains to make their operations lightning fast. And if I have to compare the numbers, in my old plan for the sequential scan, the total estimated cost was this, and here you can see there is a significant drop on this. Okay, so just by creating a single index, we have reduced the estimated work for the database significantly, and the planner itself has confirmed that. Now let's see what happened with the explain analyze, where the actual execution will happen. We will get the complete idea there. So now that I have executed this explain analyze, you see, so here this has been actually executed now, and you can see what is the execution time and all the other details. The interesting part is, again, here there are a number of things like the heap blocks, buffer, the continuation of the indexes that has happened. All these things we are going to explain in detail again into our notebook. Okay. So during the comparison, there are few things I would like to bring to your notice. So I prepared this like the actual comparison. So over here you see the final execution plan, right? So the in the final execution plan, the time over here is 36, and after I create the index, it reduces by 6 millisecond. That is one of the very important part. So in percentage wise, if you see, there is almost like 16% of the reduction in the execution time, which is a lot in the production system. Like if you just tell your product manager that I have written something which is going to reduce the timing by 16%, that's a great number, I would say. The plan and the timing here, so over here you see there is only a one long step of the sequential scan was happening, but here, if you remember earlier also we discussed, there are two things are happening. The first one is the map, that is the bitmap, and then the bitmap heap scan on the seats. So that is the part what we have written here. So we are doing a bitmap index scan, and then after we create that bitmap index, from that index we are doing a heap scan. Heap scan is nothing but like our table is in our heap. We are going there and fetching all the rows one by one from the memory. And also over here, it has, like earlier when we have seen this part, it has given us these two things very distinctly, right? Now the most important thing that I want to highlight is there is no wasted CPU mechanism, or the CPU read or write keys are there. For example, here you see, like in our earlier case, there was a row removed by filter was this many number of things were there, but over here there is no wasted work at all. And then there are things like the shard hit, it is all are happening from the RAM, but here you can see like few are happening in the RAM and few are happening in the disk as well. So this part, the buffers are not very important for us, but I just took a note of it. This like if I just again run this explain analyze select, then probably the all the things it will bring from uh, the shared hit only, okay, the cache memory only, but like you can keep it out of your head right now. So let's take the detailed analysis. So before it was this, and right now it is this 30.4 milliseconds. So right away we see a clear victory that by creating a single index, our query is about like 16 to 20% faster, and we didn't change the data or the hardware. It is simply give the database a smarter way to work by creating the index. That is why like creating the index is one of like understanding in which particular column you are going to create the index. That is one of the very important database or the application development skill. And here you can see like this part is kind of a smart strategy. When we are doing the bitmap scan, this two part they come together and do it within this 30 milliseconds, whereas for the previous one, like the sequential scan, it was the actual time was way more higher, right? And then um, there is no wasted work at all. Now this two part totally gives us this two part of the bitmap heap scan and the bitmap index scan totally gives us the amount of time it takes. I'm not again going into all the details because we have gone into the granular level for the first time. I think you will be able to make out of the meaning of this number very clearly, that what exactly is the index over here, what they meant by the time, and the actual time what they meant by the loop, right? So this is basically like any time we why this is important for the database developers or the application developer, that anytime we are running or we are creating any query in our database, we we always have to see whether there are any room for improvement or not. For example, creating blindly index is again not a very good thing. Why, we will just cover it in couple of minutes, but the thing is that like we always have to see whether we could like for very query heavy applications, whether we could improve our queries or not. And this explain plan or this explain analyze are kind of the battle tested cavalries that we have, through which we could do this sort of we could conclude our design decisions around our tables, around our queries. So now let's try to understand some details around the bitmap indexing. So what exactly is a bitmap index is? It represents a distinct value of every column as a bit vector. So suppose we are running like the Amazon e-commerce, and in Amazon e-commerce we know the most important table is the orders table. So I'm taking a very diluted example of that table. So in the Amazon e-commerce, in our table, suppose I am trying to set something like whether a value is prime or not, this sort of datas are there. So if I see a bitmap around it, how the bitmap would look like for the is prime if I create a index for this. So the bitmap would look like something like this, that whenever it is a true for a row ID, it is 1, and for if it is false, then it is 1 over here, right? Like they are kind of a invertial or completely invertial stuff, that if some row id is not having the prime capability, then we are going to mark it as 1 here. Otherwise, for the false, we are going to mark it as 1. Now this would make sense when we are going to write a query. Okay, so now suppose we are writing some query like this. For example, we are trying to get records such as this, like where the region is US and the status is shipped and whether the is prime equal to true or not. Now what would happen is, over here the database will create different bitmap index for this one bitmap index, suppose bitmap index 1, then another one for this one, this will be a bitmap index 2, and then another will be this one, this is going to be bitmap index 3. And after it getting all these things, it is going to do a simple AND. Okay, it is going to do a simple and based on this AND, all this data will come together and the final result set will be prepared. So I hope you get the idea. So what happens is, like, any for all of this column, like when the a more difficult query or a more read heavy query that you are going to you are going to try, there you are going to see that there are different bitmap indexes are being created. Suppose this three, all of them are indexed column, and then at the end you are going to see that the query planner is going to do a AND operation on top of this, and then it is going to create a result set out of that. And I highly recommend you to test this out by yourself, like just go through it, create a bigger table, and create multiple indexes around, and then you just see how the explain or the explain analyze comes when you do a query like this. So here we have covered, like in this video, a good number of important topics, or I would say these are very important topics for the application developer, where the application developers, they get to go and design the actual queries, and through this tools like the explain or the explain analyze, they are going to understand what is going behind the scenes, and further by using this sort of things we can do a lot of query optimization, right? So this is pretty much it for this video, guys. Stay awesome. See you in my next video. Bye.